The impact of aerosol pollution of indoor air on farms, animals, production and health. The methods of measurement of aerosol airborne particles and microbiological control of air quality. Livestock emit pollutants such as gases, particles and bioaerosols that harm animals, workers and nearby communities. Poor air quality causes respiratory diseases, reduced growth and increases mortality in animals. Social pressure for emission reduction is rising, but quantitative air quality standards are limited. The main pollutants are ammonia, carbon dioxide, methane, hydrogen sulfide, and carbon monoxide. Methane is from the fermentation in ruminants, ammonia is from decomposition of urine and feces, carbon dioxide is from respiration and manure breakdown, and carbon monoxide is from farm equipment, and hydrogen sulfide is from the decomposition of manure in anaerobic conditions. The other pollutants are particle matter from organic or inorganic dust, skin dander, and undigested feed. And bioaerosols include bacteria, fungi, spores, viruses, and their byproducts, such as endotoxins. So for the methods of measuring aerospores, for gaseous pollutants, we have passive samplers and active samplers. For the active samplers, it can be through absorption, where the gas becomes a liquid, or adsorption, where it joins a solid such as carbon. And there's also condensation, where the gas becomes a vapor. And then there's also direct reading devices. To assess the particulate matter levels, we use PM 2.5 and PM 10. PM means particulate matter. If the fine dust particles have a score of PM 2.5, it's linked to cardiopulmonary diseases and cancers. For measuring particulate matter, we use sedimentation techniques. This is where gravity removes the particles, and cyclone separators. This is where they use a centrifugal force to remove the particles. And there's also fabric filters. These filter dust. And they're also high volume samplers. For bioaerosols, there are samplers such as impactors, filters, and advanced DNA sequencing technologies. They focus on microbial survival during collection for accurate analysis. For the microbiological control of air quality, bioaerosols in barns are produced by animals, feed, bedding, and manure. They give health risks, including respiratory infections, allergies, and contamination of food and pharmacological products. Particle behavior is influenced by size, density, and shape. Particles can deposit in different mechanisms. Sedimentation is when particles settle on the surface, and impaction is when particles stick to the surface after collisions. This is what we use for air sampling. To manage good air quality, we need to combine ventilation with hygiene improvements, so remove manure and clean bedding, and have continuous monitoring systems to collect real-time data. There are also needs to develop standards for quantifying air pollutants in livestock settings. And there needs to be investment in new technologies for pollutants and reduction and data-driven air quality management. There needs to be an aligning of producer practices with the guidelines by the WHO and EU. And there needs to be encouragement for collaboration between stakeholders to improve livestock and worker health.